Okay, thank you, Mahendra. Thanks to Dr. Mahendra Gonçal Corella and to Dr. Ruan Visoisa for continuing this lecture series of the Sri Lanka Literary Society through Zoom during the pandemic. Welcome, everybody. Our speaker today is Professor Ravi Silva, who was awarded a CV this year for his services to science, education, and research in the Queen's New Year Honours List. For outstanding services to science, education, and research over the last 3 decades, with contributions that extend around the world. So Ravi is the director of the Advanced Technology Institute and the head of the Nano Electronics Center at the University of Surrey. He received a PhD from the University of Cambridge, and where he also did his undergraduate and postgraduate training in the engineering department. And I have known Ravi since his days in Cambridge, so for quite a long time. He's a prolific scientist and has published over 550 journal papers. And the over 18,000 citations is a measure of the impact of his work. He has facilitated the translation of research into national products in China, India, Sri Lanka, and the UK. And not surprisingly, Ravi has received several prestigious international awards, including the Albert Einstein Silver Medal, the UNESCO's Javed Hussain Prize, the Royal Society Clifford Patterson Award, the Institute of Engineering and Technology J.J. Thomson Medal, the Platinum Medal of the Institute of Materials, Minerals and Mining, the Institute of Physics James Joule Medal and Prize for contributions to sustainable energy research. Ravi has also been honored in Sri Lanka through a President's Award from the government for his contributions to Sri Lankan science and society. He holds several fellowships from the Royal Society of Arts, the Royal Academy of Engineering, the Institute of Physics, the Institute of Engineering and Technology, and the National Academy of Sciences in Sri Lanka. So Ravi is also the son of Dr. Roland Silva, the former Director General of Archaeology and a much loved son of Lanka. And I have known 3 generations of Ravi's family. So Ravi, the Sri Lanka Literary Society thanks you for accepting the invitation and for making time from your very busy schedule of going around the world and managing all this research. And we look forward to hearing about solar energy and the energy revolution.
Thank you very much, Shehan, for that wonderful presentation. If I was in the audience, I'd want to listen to me, and I hope I can live up to everything that you have said there. I hope you can see my screen at the present time. Okay, excellent. Okay. So it is really a great honor and a privilege for me to address this really erudite audience. And I am very grateful to the President and Shehan for the invitation to be able to say something with regard to solar energy and the energy revolution. But I've added the tagline, building stronger and smarter post-COVID, for 2 reasons, actually. One is that I gather the audience really has some of our best qualified people who've allowed us to go to that post-COVID period with their contributions in the NHS. So I thank you and applaud you for what you have done. And secondly, really to remind people what has allowed us to move beyond COVID has been science and technology. As a result, what you will see within my talk too is if we want to get out of the current energy crisis, we really need to look to science and technology to get to that point. So I am the director of the Advanced Technology Institute at the University of Surrey. This is this blue building that you see here. And within the institute, we've got 160 researchers who work on different forms of energy and nanotechnology activities. Our work was initially highlighted and honored by Her Majesty the Queen when we got a Queen's Anniversary Award for the work that we did in devices. And as a university, the university also have got an export award with regard to the activities that we have done on exporting high technology goods. The university is a beautiful campus, and if you haven't come to Green Surrey, you really need to, because it's probably one of the nicest campuses around. And it's very well located between Heathrow and Gatwick and London. I just have one image that I show of some of the work that we do. And this really emphasizes how everyone can contribute to a much bigger picture. What you see here is the Hyundai Pavilion at the Winter Olympics that was in South Korea. And this Winter Olympic building was covered with something called Vanta Black. These are carbon nanotube materials in the nanoscale produced over a large building. The beauty of this building was, when it was done, it was the darkest building in this world. It was the darkest building that could absorb all energy. And that material, Vanta Black, came from a spin out of our institute called Surrey Nanosystems Limited. So what this emphasizes is nanoscale objects. These are objects just larger than the atom, can actually cooperate with each other and synergistically produce macroscopic effects that allow you to absorb things on a much larger scale. Now, getting back to where we want to go, just imagine 10 years ago, 5 years ago, one of the world's most vibrant cities, one of the most cosmopolitan capitals of this world, moving from its current state to a state such as this. And these are real images. One of the busiest airports, probably the second busiest airport in the world, ending up in rows of isolated and empty seats. And places of learning such as Cambridge, where their quadrangles are empty, and King's Parade, for those of you who have visited Cambridge and studied there, completely empty. Now, this happened due to the pandemic. And it's a timely reminder for us that things can happen that are beyond our imagination sometimes. But what is more significant is that the count on our lives, again, has been significant. It could have been far worse than this if it wasn't for the doctors and the medical staff who've been working around the world in order to come up with vaccines, etc. The toll on our GDP and the country's wealth is also significant. If you take the G7 countries, they've all shrunk in terms of the pandemic, including some going into recession. But with all of this, there is hope. The vaccine has come about, and most importantly, the president of the largest democracy in the free world now believes that we do need to start looking at problems that are affecting us. We suddenly now have belief that drinking bleach is not the solution to cleaning up a disease that is basically wiping out hundreds and thousands of people. Science and technology does have a place, and it will continue to have a place. Now, with that, I'm going to move you back to history and how we've ended up coming to the current situation, not just from a COVID perspective, but also from a climate perspective. The world has been using fossil fuels at such a degree that we now have come to a point where climate-wise, our temperature that was generally within 0.2 degrees plus or minus is moving. So this is geographically called the Holocene period. For the last 10,000 years, we've had a very, very steady temperature that has allowed humanity to succeed. The present time, we have disturbed this to the point where now we are moving away from that Holocene period because man-made objects are changing the environment around us. The use of man-made products can be seen in everyday activities. And in extreme cases, you've seen pictures such as this, where the plastic waste are completely polluting not just the sea, but also islands, landfills. And this all can be put down into this beautiful view graph that basically shows humanity have actually only been on Earth for a very, very short period of time. And despite that short period of time, we've managed to muck up our environment right royally. So in historic terms, what you see in this graph is a timeline of history and the fact that in the last 10,000 years, the Holocene period, there has been no change per se to the temperature because we've managed to keep a climate that is more or less steady. But due to human-based activities, now we move from the Holocene period to what we call the anthropogenic period, where it is the anthro or the humans who are changing the environment that we are living in. So this change in environment has unfortunately come about because of the unparalleled sensation of people wanting a higher quality of life and being able to create wealth. Some say this is due to technology. And as a result of it, maybe the climate change action is a way of the Earth fighting back and saying, wait a minute, take time, start thinking, is this the best thing that you need to do? COVID, on the other hand, has given us a chance to think about things. We've had more time at home. We've had more time to think about the problems. And if there's anything positive that COVID has done, what it has allowed us to do is to look to see what happens when we cease some of our industrial activities, when we cease traveling abroad, when we cease doing things that use a lot of energy. And when we start looking at that, what you notice immediately is the greenhouse gases reduce. And with that, you reduce the CO2 levels. With that, you start reducing or plateauing some of the temperatures. But having a temporary glitch for 15 months, 12 to 15 months is not good enough. Because over the years, we have polluted the world since pre-industrialization for the last 150 years. So what post-COVID has allowed us to do is to start thinking differently and thinking that we need to build smart, build back smart. We need to have smart working technologies. We need to rethink our priorities. The Prime Minister in the last week has indicated he wants the UK to remain a superpower in science and technology. He wants us to be at the vanguard of science and technology changing the world, as well as solving some of the problems associated with getting to net zero. All of these come when we start thinking smarter and working smarter. This means we need to start thinking about what is going to happen next. And when it happens next, we don't do the same mistakes that we have done previously. And some of these things could be a transformation of your lifestyle from a standard lifestyle that you're used to, accustomed to something that is probably more sensor-based, IoT, Internet of Things based, where you have smart sensors, you've got smart cars, you've got vehicles that are running on electricity, etc., coming in. It means you need to start thinking of a more balanced approach. Now, if you don't do this, Mark Carney, who was the Chancellor of the Exchequer, has said the climate crisis would be worse than COVID. Now, it's very difficult to imagine something even worse than COVID. But here is probably one of the best known statesmen who's moved now from the Bank of England to a post in the UN, indicating that, look, take stock, think what you need to do when you go forward. Now, why have we got to this point? If we take the energy mix that we were using from a world perspective, the US and the world perspectives in this case are very similar with a few percentages movement. So from a world perspective, 10 years ago, we used nearly 80–85% associated with fossil fuels to drive our heating in our house, driving vehicles, industry, manufacturing. We only had around 8% of renewable energy usage. Now, one would say around 2010, there was enough information out there on climate change and that we had to do something. If we look a decade later, and this is as close to the complete figures that we can get, we moved from 8% renewable to 11% renewable. It's not a huge amount. We have less than 2% of solar and wind currently being used in the world today. So the problem at the present time is that over 80% of our current energy that we use, from heating to driving to manufacturing, is from fossil fuels. And that has been the same story for the last 3 decades. The problem with this is, with use of fossil fuels comes emissions, particularly CO2 emissions, that are polluting the earth to the extent of something like 35 gigatons of CO2 equivalent on an annual basis. Now, interestingly, this is not a problem fixed to a country or a continent, because we got only one Earth. The gases I put out from my flue, from my house, affects the rest of the world. So as a result, this is something that we together have to come up to solve the problem. It's not a problem for the rich, it's not a problem for the poor, it's not a problem for the developed, it's not a problem for the developing world. We all are in the same position when it comes to climate change. What scientists have showed without a doubt is this correlation between the CO2 levels and the temperature. So what you see in this graph in blue is the CO2 levels that have been steadily increasing past the first industrial revolution, second industrial revolution, third industrial revolution unto now. And we knew by about 1970 that if we pass a critical level of 350 parts per million CO2, we would go beyond a particular turning point. And we currently are at about 420 parts per million CO2. Now, unfortunately, what that has done is, it has also pulled the temperature, which is shown in red here on the axis on your right here. And that temperature rise appears to be following the same trend associated with the CO2 levels. So for 10,000 years during the Holocene period, we had plus or minus 0.2 degrees. Now we have gone 1.2 degrees beyond the pre-industrial stage with our current emissions. And our current emissions cannot be turned off, because if we do turn it off, that means you wouldn't have power tomorrow. So the question really is, how do we balance this? Now, if you don't balance it, we are seeing those effects everywhere around us. There is chaos in terms of storms, typhoons, climate change in terms of the melting of the glaciers. There are ice storms happening close to the equator. And this is all due to the fact that we have a problem associated with the fact that the CO2 levels are increasing, and with that, it's increasing the temperature. So this is the point in which the various governments of the world came together in 2015 and signed up to the COP26 Paris Agreement. 196 nations came together and signed to this, saying we need to get to this point net zero. Now, why do we want to get to the point net zero? It's because if the world is to manage the temperature rise to within 1.5 degrees of the pre-industrial level, the IPCC, which is an international organization on climate change, have calculated that by 2050, we have to get to the point of net carbon zero. If we don't do that, there will be catastrophic effects in terms of climate change. We are already seeing that from the point of view that there are more extreme climatic events in the last decade than the last century. Now that emphasizes how quickly the climate is changing in comparison to everything else that is happening around. Our current status is this, where we are putting around 35,000 tons of CO2, gigatons of CO2, anthropogenic greenhouse gases, compared to the removal, where there is certain amounts of gas always removed due to the forest and the bogs and the marshes taking in the CO2. So for example, the ice freezing up in the Antarctic and the Arctic also takes up CO2, but with the current rise in temperatures and the melting of the glaciers, that's releasing the CO2 that was captured even within those glaciers. So it's not only contributing to the increase of CO2, but it's also contributing to acid rains as it mixes with the air and the environment. But we have no choice. We have to get to this point shown here on the right, where there has to be a balance between the anthropogenic gas emissions and the anthropogenic removals if we want to save the planet. Just to show how sensitive this is, if we miss our 1.5 degrees and say the temperature rises to 2 degrees by the turn of the century, so this is not by 2050, but by 2100, it is estimated that 11 million more people will be exposed to extreme heat. 61 million people will have drought. 10 million people will have increased sea levels. So effectively, what it means is that you could have temperature rises, increasing sea levels, flooding, the desertification, acid rain, all giving rise to huge amounts of displaced people, refugees, water contamination, disease, damage to infrastructure, interruption. And this is just a side effect of global warming. So what I want to do in the next 3 or 4 minutes is just to show you something that has been pulled together.
It's the general scientific consensus that climate change is causing an increase in extreme weather events around the world. Oh my God. From sea level rises to droughts, extreme weather can seriously cripple affected communities. But what is considered an extreme weather event? Extreme weather can be very dramatic, with fire tornadoes, wildfires, severe tropical storms, hurricanes, and cyclones being the prime examples. According to the Intergovernmental Panel on Climate Change, an extreme weather event is an occurrence that is more severe than the historical norm. They point out that even statistically, non-extreme weather events can cause significant damage to economies, societies, ecosystems, and infrastructure. As of 2012, there have been more than 800 major extreme weather events recorded worldwide, causing hundreds of billions of dollars in damage. Other sources, like the UK Met Office, show a marked increase in extreme events which caused loss from just over 200 in 1980 to over 700 in 2015. In the US alone, the National Climate Assessment indicates that events like heat waves, heavy downpours, and major hurricanes have noticeably increased in frequency and strength over the last decades. In fact, over the past 30 years, the United States has experienced some of the worst weather events in its history. Take Hurricane Katrina, for example. In August of 2005, the hurricane hit Florida as a Category 1 and evolved into a much more powerful Category 3 along the eastern Louisiana, western Mississippi coastlines. This storm damaged infrastructure and ultimately led to the levee system of New Orleans being overwhelmed. More than 1,800 people lost their lives, and repair costs were estimated to be more than $160 billion. Not to mention the wildfires that ravaged Australia at the beginning of 2020 and the recent fire tornadoes in California. Are these extreme weather events really a consequence of climate change?
So I'm going to stop there but hopefully what it has shown you is these extreme events are extreme and they're happening more and more frequently. In fact, if you look at the news today, you see what's happening in North America, in Canada, where there's a heat wave going. And in addition to the heat wave, you've got lightning strikes that are starting fires. Similarly, in Australia, you have the fires. In California, you have the fires. So these are events that keep happening more and more often simply due to changes in the climate. Now, is there a way around this? If we start thinking, what is it that sustains life on Earth? Maybe there is a solution. Maybe there is something we can learn. At the end of the day, if we start thinking about what sustains life on Earth, it's basically the energy that comes from the sun to the Earth. It's the energy that the crops use in order to transform your chlorophyll into carbohydrates. It's what farmers do in order to use their cattle who are grazing on these farmlands to produce meats. And in terms of houses and our own everyday life, it's the fossilization of these trees and animals over tens and thousands of years, millennia, that have given rise to the fossil fuels, coal, petroleum, and natural gas. Now, it may take 1 million years in order to fossilize these systems, but when you burn them, you are releasing CO2 that has been captured over those millennia in a matter of seconds. So knowing the fact that the sun is the source of our energy, is the source of life for humanity, is there a way that we can remove that link and go straight from solar into energy without going through the fossilization stage? Clearly, the top half of it is possible. If we become more vegetarian and vegan in our lifestyle, we probably will be able to have a more sustainable lifestyle. But if we want to run our industries, if we want to run our everyday lives with the luxuries we are used to, we need to be able to somehow or another power our lives with suitable energy sources. Now, as a physicist, you could then take the problem and say, let me first start off with the basis of how much energy comes from the sun to the earth. Now, this we can calculate based on Planck's blackbody radiation law. And based on it, I can do a physics problem that allows me to work out what the temperature on the sun is. And then I use Stefan Boltzmann's constant sigma. And based on that, I can say the amount of energy that I get from the sun is shown here on a daily basis. So the amount of energy that comes from the sun on a daily basis is 173,000 terawatts of energy. Now, if I equate the current world energy use, that is equivalent to 15 terawatts. Now, let me emphasize that again. The sun gives us 173,000 terawatts on a daily basis. The world uses 15 terawatts. What that means is within 1 hour, if I can collect the energy that hits the earth from the sun, I can power the world for a year. There is a 10,000 oversupply of energy coming from the sun to the earth, provided we have the technology and the science to capture that. And that basically is one of the biggest problems facing humanity today, in being able to capture that energy. So this is one of the grand challenges that we as scientists face in how do we go about doing this? Is it possible? Now, if we start thinking about potential and capacity, is the sun the only source of energy? What about the other sources of energy? And what this diagram tries to exemplify is the fact that if I were to map out the amount of energy I get from the sun, which is shown in this yellow cube, relative to that, the amount of energy I would use as the human race in 2050 is represented by this little cube here. So it basically shows that if I can efficiently harness some of these solar energies coming in, I can certainly power the world. Just for comparison, the total amount of coal in this world is shown in this dark gray box. The total amount of gas and oil are shown in these white and gray areas. So solar, by a large margin, is the most abundant energy source available to us. So it really is a no-brainer if it comes to looking at what technologies we should back if you do want to go and have a sustainable energy supply. If I now look at the cost associated with utilizing that energy, Silicon is the preferred material that is currently used in order to be able to provide your solar cells. And if you look at the solar cell costs over the last decade from 2010 to 2020, what you see is a steady decrease in price. The shaded greenish area that you see on all of these curves is the cost of fossil fuels, the range of fossil fuels. And this range is in per kilowatt hours. So effectively, oil, coal, and gas ranged between about 5 US cents per kilowatt hour to around 16 US cents per kilowatt hour. So if you look at your gas bill, you're probably paying about 12 to 15 pence per kilowatt hour. Your electricity bill probably will be also of a similar number. But what these curves show is that with the increase in technology of solar technologies, this price of solar cells and the ability to harness that energy keeps going down and down. And at present, this curve has actually gone below that of the fossil fuels. Similarly, in the case of wind, again, the wind energy has been low for a while and it has gone below. In fact, the government report that came out early this year, late last year, from BASE, the Department of Business, Energy and Industrial Skills, showed solar and wind as the cheapest forms of energy, and the cost of energy being less than half that of nuclear energy. So there is no doubt that solar and wind today forms some of the cheapest energy that is available. In fact, if you look on the web, you will find in the last month, solar electricity has been sold at less than 1 cent per kilowatt hour in world auctions. So there are PPAs, power purchase agreements, being discussed currently in the world. You can buy solar energy at less than 1 cent per kilowatt hour. Now, if energy is so cheap, there is a question as to why the UK and countries such as ours are still going down Hinkley Point C, where for Hinkley Point C, we have agreed a 35-year contract of £92 per megawatt hour, or nearly 9 cents per kilowatt hour, when we can get solar at less than a fifth of that cost. So that is a question that has to be asked. But on the other hand, when you want to power a nation, you need to have a mixed basket. And we know wind and solar are intermittent. So as a result, you need to have different forms of energy. But worldwide, if we start looking at deployment, and I've used 2017, 2018 here, simply because not to be affected by COVID, the largest amount of deployment worldwide of energy sources was solar by a large margin. So nearly 55% of the new energies deployed in the world came from solar, 32% was offshore wind, 10% was, 32% was onshore wind, 10% was offshore wind, and the rest were small percentages. The UK is looking at its energy provision very carefully. We do believe we can get to the renewable energy targets that are needed for electricity. And certainly nuclear is a clean energy, although in my view, it's not a green energy. We've got a number of different acts. We've got the latest 10-point plan that was released by the Prime Minister. And we also have got new power links that are being put underground, effectively linking us to Europe, that allows us to buy hydroelectricity from countries such as Norway in the future. So therefore, at the present time, solar energy will be brought in, or renewable energy through other sources to the country. Now, as the audience have a lot of Sri Lankans there, I thought it would be useful just to have a quick look at Sri Lanka and its links to this. And it's very important that Sri Lanka, being close to the equator, has an energy flux that is about 60 to 80% more than in the UK. As a result, we should have a significant amount of energy that we can harness from solar energy. Yet, we have not done so. And at present, hydroelectricity that we've had for probably the last 60 or 80 years constitutes the largest chunk of energy we currently have, of nearly 40%, with around 10% of renewables with solar and wind. Now, I did a small study with some friends in 2017-18 to see whether it was feasible for us to actually move the country from its reliance on oil, coal, and gas to something that is more renewable. And when we did the study, what we found out from the literature was that at that time, renewable energies constituted about 50% of our energy market, with the other 50% coming from both coal and oil. Now, if we want to transform this other 50%, we certainly had the means of doing so, because the numbers in Sri Lanka are not that large. So, for example, the total installed capacity was around 4,000 megawatts or 4 gigawatts. And nearly half of it was already coming from renewable energy. So we were looking really to replace 2 gigawatts. You can also look at the peak power demand. And in the case of the peak power demand, it was about 2.5 gigawatts, which meant that you only needed 700 more than the installed hydro power in order to make it a stable base load. Looking at Sri Lanka over the years, in terms of generation, and these from 1998 to 2018, hydro has been quite stable and has given the base load that is needed. We've used oil since then, and sadly for me, from 2010 onwards, we started putting coal, which is the most polluting form of energy, and we still want to use more coal when there is no more coal being used in the rest of the world in terms of energy generation from the developed countries. The other renewables are still small. The 20-year plan for Sri Lanka also is quite modest, where it's stated that for the next 20 years, it needs about another 8 gigawatts of power, with 4 gigawatts coming from renewable and another 4 gigawatts coming from oil and coal. Again, this is not great, because the country keeps going back and saying we want to go into oil and coal rather than going to the new technologies. In our study, to cut a long story short, we basically looked at what the government has promised in 2017 and in their 10-year study. And there was a cutoff date after 5 years that they should have certain amount of ground-mounted and roof-mounted solar. Unfortunately, that doesn't seem to have taken place, but there are grand plans in order to take that further. And I think some of the new plans are certainly very ambitious and exciting. But within our study, what we said was that if we really wanted to get solar into the country and to wean the country out of the coal and oil, what would be great would be to have around 10 solar parks of around 20 megawatts distributed around the country. And we went as far as saying, looking at the power that is being used within the country, that we could distribute it in these places, Kilinochchi, Vankalai, Dankotu, etc., the white dots that we have shown there. And effectively, if we wanted to power the whole country, all you needed was the space twice that of this diamond shown here. So space-wise, it's not a huge amount. And that's something that we have to remember, because the old argument of saying solar takes a lot of space is no longer a valid argument. It does take space, that's for sure. You need about 4 acres for every megawatt of energy. But relative to the areas that are used, that are uninhabited or just waste, it certainly is an area that can be used. The newest 2 projects that the Sri Lankan government have announced is in Punarin and Monaragala. And what they're saying is that they would like to have 100 megawatt parks based there. It's interesting, within the plan that was put in 2016-17, we suggested Kirinochi, and now they're saying Punarin, and we had one in Lahugala, and there is one that is being proposed in Monaragala here. But these are very welcome. These certainly will be helpful for the country, but we need many more of these. The Sri Lankan government is very ambitious, and they have said that they want to go to 80% renewable, and this was a plan put in 2020. And I believe this is a plan that is going to be pushed forward at the COP26 in Glasgow. I think I wait with interest to see how this goes along. I have looked at the possibility of taking a consortium to start work effectively in Punarin, if there is suitable space to do so. The problem at the moment is that within Punarin also, the allocated blocks are so small that you cannot take any major large company or conglomerate there, simply because the scale that is being offered is too small for it to be commercially viable. But this is exciting. I hope the government are able to deliver on this. And if they do, there's going to be great scope for a lot of new energy-based technologies to be coming into the country. The country also is blessed because we've got this beautiful hill country in the middle that has all the various geography needed in order to be able to have a hydro system. And if we already have 38% of our energy being produced by hydroelectricity, pumped hydro would be a beautiful base load to have, so that when the sun is shining, you use as much power as you want. The rest of the power is just simply used to pump up water into your hill country, so that when in the evenings, when the sun is no longer shining, you pump it down and generate your electricity. So as a country, Sri Lanka probably is one of the most beautifully placed test beds available to try out this process, where you don't even need to look at major large energy storage units, because we use our hydro as our base power. So it's something, it's a challenge to the government to see how they can react. From a world perspective also, we can actually calculate the amount of energy that is needed. And this has been done. And just to emphasize to you the space restrictions that people used to talk about, what you see here in this view graph is the world map. On superimposed on it are these small square blocks. These square blocks basically represent the amount of power needed to power the world in that region. So what this is telling you is, if I want to power North America, I need to have 3 linked installations of solar power farms, the equivalent of the size of the green dots with the red border. If I want to power South America, again, 3 dots. In the case of Africa, you'll have one in the Middle East and one near South Africa. And the area within this curve with 20% efficient solar cells can give enough energy for the whole region. Now, clearly there are many more technical hurdles that need to take place, i.e., you need to have power distribution from that point all the way, and lossless cables, etc. But this is just a hypothetical case where it emphasizes the space requirement is no longer a major concern. You can have local power delivery to that local point as long as you can get a suitable balanced load with necessary backup power. So it's something that we really need to think carefully and we need to take seriously. And whether we like it or not, solar energy will be coming to your door soon. Now, what happens next? So it's not just necessary or suitable to think of the current state. The current state means that you can make solar cells that give you roughly 20%, 24% efficient devices with silicon. We are also working on what follows that. And what we are working on is plastic solar cells, where if my crystalline silicon solar cell was 300 microns thick as shown here, the next generation of solar cells based on plastics will be 100 nanometers. So 300 microns go down to 100 nanometers. A nanometer is 10 to the minus 9 meters, or 1,000th of a micron. So I can reduce my 300 microns to less than 2/100ths of thickness and be able to absorb the same amount of energy that I absorb in my silicon within my plastic electronic solar cell. The plastic electronic solar cell will also be based on solution processing. So these are inks that I buy. These inks that I buy then can be sprayed onto plastic substrates. And those plastic substrates basically can be printed on these machines, much like you print your newspaper. So it's strange because now we are saying most newspapers have gone out of business because of the internet. So maybe this is a good opportunity to reposition the newspaper conglomerates into printing solar cells. And by doing so, you now have a technology that is plastic electronics that can be made in this format that can harness the energies similar to silicon, but it's using 1,000th of the volume of active material, which means I can reduce the cost of silicon even further. So if silicon solar cells are giving me power at 1 cent per kilowatt hour, I can potentially decrease that cost by 10 times to 100 times by going down this route of plastic electronics. And using this technology, we've already demonstrated these large solar sails and canopies, etc. And this is the technology of the future that we are looking at in order to be able to produce devices that are suitable. And just for completeness, you need to also think about the next technology that follows, and the very next technology that follows is the perovskite area. And some of you might hear about these perovskite materials that will follow on from the organic materials that we are working on. So let me sum up now my talk, because I've come to the end of the 40 minutes allocated. why do we want to start looking at revolutionizing energy? Is it because it's a fad? Is it because it's a good technology thing to do? The answer is no. Energy revolution will allow us to democratize energy. It will allow us to bring social change, environmental change, and economic change. It will make technology much more affordable to the many. So we hope it will give a truly sustainable solution for the people. And it's the people that we are trying to support here. And it's development that does not compromise the future generations of our own kids to be able to meet their needs. We believe with suitable energy systems that are cheap enough, we will be able to help bring forward the sustainable development goals, the 17 sustainable development goals that have been put forward by the UN. And finally, because of the erudite company that I'm keeping today, I thought I'll throw this in. I think as a Sri Lankan, as a citizen on this earth, it is our heritage that this is brought to us. If we think of what the definition of a heritage is really something that is handed down generation to generation, a tradition. It's something that we inherit from our forefathers. And much like we are used to having the freedoms around us, free water, free light, free air, free solar energy should be part of our heritage. And maybe when we next look at the UN, where the UN has defined the white lights from St. Petersburg as a national heritage, the Great Barrier Reefs as national heritage, or even the view that we have from Horton Plains in New Delhi as heritage, maybe the light around us can also be treated as it. And with that, we end up looking at the sun much more than just an object, but really it's the life on Earth that will be sustained by the sun. So energy allows us to have high qualities of life. And at present, unfortunately, it's a fossil fuels that gives us most of the energy, so 80% of the energy. What we need to do is to break that tradition and insert renewable energies into this. And if we really want to get to carbon net zero, we have to go down that route. And at present, renewable energies via solar is probably the most promising route to get to that point. So with that, I thank you for your attention and be very happy to answer any questions that you have on this topic. Over to you. Thank you very much.
Thank you, Ravi, for illuminating us on and making us think on how to solve these energy problems. And first of all, I'd like to ask you a question, and then it will be open to everyone else who could. My preference is if you would put your questions through the reactions box, because I can see your hands going up, rather than losing your questions within the comments, with the comments in the chat box. So I just wondered, what made you choose nanotechnology in those early days when I'm sure, like most of us, several avenues were open to you? So what made you go down one alleyway and not the other?
Thank you, Shehan, for that question. It is an interesting one because it's actually another Sri Lankan who actually made me do that. Not that he made me do that, but made me think to go down that. It's Professor Gehan Amaratunga in Cambridge. After I'd finished my undergraduate work, I was very interested in doing electronics and fast electronics. And I wanted to do work that was going to be work with gallium arsenide and looking at the next fast hot electron mobility transistors. And I went to the head of department at that time, Alec Browers, who's Lord Browers now, and asked him saying that I'd like to do this. And he said to me, look, gallium arsenide had been the technology of the future for the last 10 years. Why don't you look at this new types of stuff coming through? And this chap called Gehan, he seems to be doing something completely bizarre. So I went to see Professor Gehan Amaratunga in Cambridge and spoke to him. And it was true, he was doing bizarre stuff with looking at carbon-based nanomaterials. And from the first 5 minutes of my conversation, I was hooked. So as a result, it's interesting, some of the work that has come out in graphene in 2004, we actually looked at that probably 8 years before that, but we didn't come to the point where Koster, Novoselev, and Andrei Guy were able to fully define graphene. We went up to a point and stopped. So I think it's certainly Gehan who has to take the credit for coming to that point and guiding me in that direction.
All right, thank you. So there are 2 hands up already. It was Ari first, and then it will be Rohanta Fernandez. Ari, would you like to unmute yourself?
Thank you very much. Can you hear me now?
Yes, we can.
Thanks. I'm sorry about being invisible. I have a problem with my imaging system on my PC. For the purpose of clarity, I put my question in the chat box, but I'll just summarize it. Essentially, it's in relation to, well, it's a question to Professor Silva. Thank you very much indeed for your very enlightening presentation. Very much enjoyed it. My question is about Sri Lankan state of affairs. I think you did refer to the Sri Lankan circumstances, but I remember a report being released back in 2016 during the regime of President Sirisena that our solar energy power ability, or at least the potential, was some 32% of the annual power. But then there have been some reports about the challenges that go with it, namely the cost and the intellectual property rights exercised by those conglomerates that you mentioned. Can you brief us on that, please?
Absolutely. Thank you, Ari. That's a really good question. And you're absolutely right. President Sirisena did want to bring this, and he also introduced the rooftop solar system in there. The major problem I see we have in Sri Lanka, and it's a personal opinion, is the cost of getting internationally competitive organizations to come into the country. And I can take the example of the Hambantota solar installation that was put in. Now, when the Hambantota solar installation that was put in, which was meant to be up to 10 megawatts, the cost of solar power per kilowatt hour is probably 6 to 10 times higher than the cost you would normally expect and see in India. And that is associated with different facilities that have to be brought in by the different organizations that bring things in. So for example, at the moment with the Punarin situation, as I said, I've tried to take in a consortium. So the consortium have been given the rights to build their solar installation and sell their power. But in addition to that, what they say is that the company that does this has to deliver the power from their base station to the network with a 4-kilometer run of power lines. Now, in order to get your 4-kilometer power line, you need to negotiate with a number of parties in not just getting the most suitable route, but also getting various access rights, etc. So I think, like in India, if we can have solar parks where major organizations can tender to look at large chunks of energy being supplied through power purchase agreements, there will be major companies that come and deliver it. At the moment, as I said, the most competitive price is 1 cent per kilowatt hour. And you can compare that to whatever price you have in the UK or Sri Lanka, and it's way cheaper than anything else you can get. But this will only come if you have large, sizable chunks of solar farm available. At the moment, no major company like 8 Minutes or Trina will come in unless you have a minimum of 100 megawatt plot given to you in order to deliver your energy. They need to have that scale of size in order to be able to deliver the cost reductions needed. So it really needs to have a suitable governance structure as well as a thought as to how to set up your procurement in order to deliver. So it really is about getting the right facilitation in the country to be able to deliver this. So I think it'll happen, but it'll take a little bit more time before we have the right environment in which it can be delivered with the cost savings that are proposed.
Thank you very much.
And it's Rohanta Fernando next. Please unmute yourself and ask the question.
Can you hear me?
Yes, I can hear you.
First, to say how much I enjoyed the talk, and I'm glad it was hopeful. The second thing is this kind of new nano solar cells, can they be manufactured in developing nations?
Thank you, Rwanda. That's a fantastic question. And I think absolutely. And that's the beauty of the nanoscale structure. Whereas previously in the semiconductor world, it was very difficult to compete unless you had a $1 to $10 billion to set up your infrastructure. In the nano world, you don't need it. So it's certainly something we really need to look at quite carefully. And I believe certainly in Sri Lanka, we've got SLINTech, Sri Lanka Institute of Nanotechnology. If we can get enough experts within the world to work with SLINTech, we should be able to come up with our own type of nanoscale structure. We also have some very talented researchers. So I think there are researchers in Uva University as well as Jaffna University who are working on solar technologies, but they need to have the necessary facilities to be able to develop these in Sri Lanka.
Thank you very much. Thank you.
Next is Ranjit Vijayaratna, and then it will be Indrajit. So Ranjit first, please.
Yes, thank you. I really enjoyed that talk, Professor Silva. My question here is, why are we talking of ground-based solar parks when there's limited land available? Why not go for floating solar? Isn't that a possibility?
Absolutely. You're absolutely right. Solar floater has come very, very strongly recently. And I think at one stage in Sri Lanka at the moment, there is a proposal even on the Bay Area to try and start putting some floating solar to start with and examine. Like in everything else, the complexities are slightly more severe, particularly if you start looking at floating solar on sea rather than fresh water, where there could be significant corrosion with the sodium and the evaporation of salt water hitting the panels. But it is absolutely feasible at present to look at floating solar, and that's something that is being looked at. In fact, in India, Prime Minister Modi is saying that all waterways in India has to have a canopy of solar put in the next 5 years. So he's trying to do two things. One is to use that land that waterways are using, but also to stop the evaporation of water by getting to the solar before it hits the water. The key is really to come up with a new type of material that can give the stability to your solar cells. And secondly, it's the access to the solar cells in case something goes wrong, because no major international company would want to keep coming back and fixing something. So as a result, they prefer ground-based to floating solar. Now, even in the UK, we've just started the largest solar farm in the UK. So if you look at Cleve Hill, 350 megawatts of solar in Kent. And this basically subsidy free. So it's the first time in the UK that a company has basically told the government, we don't care about any monies you give because we know it's going to be profitable. So we are going to do it. So it's a very interesting time for solar.
Thank you very much.
Thank you. It's Indrajit next. You need to unmute. We can't hear you. You need to unmute yourself. You're still muted. That's fine now.
Nice to hear a Sri Lankan from at Cambridge. Thank you very much for your talk, Professor. I come from a village called Katana near Nigambu. I built a few houses for the folk who were working for me when I sold my estate. And their first question was, how much api kohomada මේවට සල්ලි ගෙවන්නේ මේ electricity වලට. So I went and checked around to see if there was any individual solar panels that I could get for these boys whom I had built houses, but it was so unreliable. Could you let us know what is the current status of affairs in Sri Lanka or any part of the world, please, so that we can purchase reliable sources of energy for these little houses?
Thank you, Indrajit, for that question. I come from Girul, actually, not too far from Katana. So my family is from also the sort of area. And basically, at the moment, it's still high in technology levels for if there's a fault in something for it to be fixed. But on the other hand, most solar cells now will give you 25 or maybe even 30 years of guarantees for lifetime. So therefore, it is highly reliable technology. Now, in terms of getting reliable solar, I think this is something, maybe it's a very good idea for us to propose to the government that they really should try to do this through the Renewable Energy Ministry, because much like the subsidies that the farmers have in getting fertilizer in order to produce their crops, maybe we really need to start thinking about empowering people in Sri Lanka in giving soft loans or whatever with high quality solar cells being provided. Now in India, they already do this sort of thing, and in particular Tata have got activities in many cities that produce high quality solar cells that are integrated to building materials. So I think that's a very good idea, and it's probably something that should be proposed, if possible, to the policymakers in providing it. But you can get high quality solar cells, but still in Sri Lanka, there's a lot of taxes associated with these products. And I think that's where, unfortunately, it becomes slightly unaffordable in the current climate. But it is certainly something worth talking to the government about, particularly because of the links the current government have with China. China is by far the largest solar cell producer in the world, and they probably have 8 out of the top 10 solar cell producing companies around. So therefore, I think that's a very good proposition to look at going forward.
I was wondering whether Girula Mills is turning to solar energy.
We do have a green energy activity, and there is some work with Lolu Agodai.
Thank you.
Thank you. It's Lal and Shanta next, and then Mahendra. I can't hear you.
No, not yet.
I can hear you now.
Okay. Thank you very much, Professor, for a very interesting and informative presentation. My question is, when do you think the nanotechnology products that you're developing will be available in local market? I mean, anything for domestic usage?
Okay, thank you very much for that question. It's a very good question. I think many of the products that we are doing here in the UK are under license agreements, so therefore it's already there. It's already in the market. They are available. But interestingly, in Sri Lanka, if you go onto the web and you look at Slintech, we are actually selling it with the Slintech branding. So I use Slintech is the Sri Lanka Institute of Nanotechnology. It's an institute that I helped set up in Sri Lanka, where we have about 100 researchers who are looking at technological solutions. So in the COVID time also, we helped increase the capacity of looking at asymptotic testing associated with the LAMP testing. We are also now putting anti-microbial coatings on all products from Atlas that are selling to school kids. And in some books, we are doing that. We're working with a number of companies on slippers, on the clothing with MAS and Brandix. And in all of these, we are putting nanotechnology in. In some companies, they allow us to put a label saying powered by Slintech, whereas in most places, it's not there. But we are having more and more nano products coming out at the present time.
Thank you. Thank you very much.
Mahendra next, and then it will be Kishan after Mahendra.
Thank you, Ravi. As expected, wonderful presentation. I have two questions. One is related to what Shanta just asked you. How far, I mean, I'm thinking of moving from individuals to populations. In population terms, you need parks and so on to produce massive amount of energy. And then you can move back to individuals. So in terms of individuals, are we quite far from having car roof painted with solar panels, if you like to charge the car? How close are we to having much more efficient roof system for our own houses to produce energy? And are we any close to producing road surfaces, which nanotechnology is there to generate electricity for cars which are moving on it? Are those things pie in the sky, or are they really happening or going to happen soon? That's the first question. I'll ask the second after the first one. Yeah.
Okay, sure. So in terms of populations and what people can do, I think at the moment, whatever technology we come up with takes probably 5 to 10 years of testing, consumer testing, before it is given to consumers. So as a result, the ones that have been tested associated with the silicon solar keeps getting cheaper and cheaper, while we try to produce products also that are cheap. So we do sell some plastic electronic solar cells currently. When I say we, I mean the sector to large conglomerates. So one of the companies that sell it is called Armor, and these are the people who produce large area plastic solar that can go on top of surfaces that include shops, etc. Heliotech is another company that produce solar cells that you can buy on the large surfaces. So you can get it, but they're only given to selected customers who will help produce it, simply because we don't have the necessary expertise on the volume of manufacture as yet. So I would say it'll probably take 3 to 4 years before we can start seeing some of these plastic electronic products coming out. But it's getting closer and closer, and there are companies that are able to sell it. With regard to the road surfaces, it's an interesting point. There was part of the M3, I believe, that was looked at in terms of regeneration of energy and whether that was feasible or not. And in that case, it was looking at some electromagnetic energy regeneration. And I don't think it was as successful as we thought it would be. So I don't believe that testing is continuing, but it is something that is being looked at whether you can generate energy from the roads in powering just the signs and various other aspects associated with it. But it won't be more than that. It will be purely local use. But in all of these, you need to have a smart grid. And that's probably going to be the biggest challenge, because all areas in the future will have local power sources rather than the national grid, etc., bringing power to the areas.
Okay, thank you very much. My second question is partly philosophical, partly conjectural, partly political. I was just thinking through the stages of the need. Firstly, we have to demonstrate to the population, the world people, that climate change is a reality and it's not fiction. And thank goodness there has been a change in America, which has hopefully helped in that process. Secondly, once we convince people, then we need the people to rise up and say we want it, so the governments can be influenced. And then now the political part. I may be wrong, but I believe that the world is at the moment driven by profit. People are doing services. A lot of the big companies are doing services to make money. And I firmly believe that just like water, energy should be something that is given to the people as on a non-profit motive. Energy should not be sold for money. It should be provided for people. And so long as you have this current system of profit-making, conglomerate-driven consumer society, that will be difficult. Because from what you say, it seems eminently possible to get things going. But there are lots of people who are going to lose out if this goes public and is managed by governments, in other words, without making money. So do you think that I'm imagining, or is there a political problem here in getting things going?
Okay, thank you very much, Mahendra, for that question. And I'm going to answer it in reverse order, because I fervently believe in what you say. So you're speaking to the converted here. I personally believe it's a God-given right for people to have power, much like water and air, because this is the energy that is coming from light. I do believe that by 2035, so again, I've written a paper on this, that the cost of energy will become lower than 2 to 3 pence per kilowatt hour. And what will then happen is that it will not be profitable for major companies to be able to charge for it, simply because it will be too small an amount. So it's a bit like the mobile phone era, where 20 years ago, people were charging for you to pass data. It was a data rate given, a data number driven process. Then it became more a service provision. And now it's become free even then. And it is about how good a service can you do. So I think energy also will come to that point where it's so cheap that energy companies will stop charging you for the energy you use, but they will charge you for having uninterruptible supplies, or supplies that can give you large quantities of energy. So it will be a mixed bag. So that will be the true democratization of energy going forward. And I hope that will happen probably 2035 onwards. Simply looking at the numbers, it won't happen any before, because there is profit still to be made. So that goes on to your second question. And it is basically the profit making that really dictates what services you can buy. And at the moment, energy is profitable. Ironically, in the Middle East, one of the major changes that are currently happening is a drive to go into solar energy. Now, Middle East, that has got the largest reserves of oil and gas in some cases, is wanting to go into solar energy simply because they believe that they have so much solar energy that they can probably replace some of the oil generating monies with solar energy. And with the solar energy, they can also use it to generate hydrogen, which then starts becoming the fuel of the future. So there is a lot of political maneuvering and major corporate positioning that is going on at present. The one other example I would give is with regard to climate change and people. I do believe universities need to show or do the walk rather than the talk when it comes to climate change and carbon zero. So as a result, I managed to persuade the University of Surrey to go into a net carbon zero. We've pledged to become net carbon zero by 2030. Now the government pledges by 2050. We believe we can deliver net carbon zero by 2030. And if the universities can do it, I believe the towns and the councils can also start following that example and start convincing people they need to work together in order to deliver that. So the way we are trying to do that is by having large solar farms set up within our university premises, but we need to still get permission from our councils in order to get that put in place. But we are trying to galvanize people power through that route in order to show them that they cannot continue to disregard the climate, because it will be too late soon. And if it does go beyond that turning point, you really wouldn't have an environment that you can enjoy.
Thank you very much.
Thank you.
Kishan, you're
Shihan, you're on mute.
not Kishan, Shihan.
Yeah.
Yes.
You want me to
Yes.
talk or?
Yes.
I guess you can hear me well.
Yes, we can.
Yeah, Ravi, thanks. I think you're quite right about the pricing on solar and how sort of as a country we could benefit from that. But I'm still a fan of a particular technology called small hydropower in Sri Lanka. It goes back to, I think, now 25 years. And there's a lot of talk about that have been exhausted, but I still feel that there is plenty of, a small hydropower capacity available. And the simple reason is, if you really compare the direct cost, what you said is probably right. But when you really look at the delivered cost, if you have to look at, I think, the infrastructure that have been laid out there for the small hydro, which probably we can consider as sunk cost right now, there's approximately 1,000 megawatts absorbable as of now. And also those are in areas where the energy can be distributed so that, it can probably be used with less transmission losses. And then in terms of the dispatchability of this segment, it's we all know it's far less intermittent. And then I think we also have this whole sort of tank system in the east, which is only fed in one monsoon. But if you go to the irrigation department site and get onto the GIS data, you would see the eastern in the eastern area, the tanks are still about 40 to 45% sort of their storage capacity, which means they're stored energy. So my question is, when you really look at the delivered costs and contextually that, there is additional cost perhaps required to actually bring in intermittent sources, what is your view about actually developing the small hydropower capacity prior to sort of, looking at maybe more intermittent resources?
Okay, thank you, Kishan. That's a great question, right? And I absolutely appreciate it from the point of view that, as I've said, I think solar goes hand in hand with hydro, particularly in Sri Lanka. And solar needs to have storage if it is to win out. And having small hydro is the perfect mix. Some would say the yin and yang associated with energy, having the two together. So you're absolutely spot on that Sri Lanka has got the best geology possible to be able to do both of those together. Now, in terms of rest of the world, I think solar is slightly more democratic because they don't have the right geography necessary in order to have waterways, etc. Now, if you go to Norway and some of the Scandinavian countries, you have 80% of their energy run by hydro. So it's got a perfect system. In Sri Lanka, we do have it certainly in the hill country, etc. And we'll certainly have to start building on that. And I think currently, if we can get the right power purchase agreement and the right partners coming to Sri Lanka, they will immediately start building initially on solar and then find that they need to store that energy, and it will go hand in hand. So my vista of the future for Sri Lanka is a truly green solar company that really looks at hydro and solar together with wind and all coming together. It's a very interesting point you note, because people probably don't know, even in Windsor Castle, the Queen has a little hydropower plant in the back garden, right? So they do use hydro even in areas where you think it's not that feasible, but it doesn't run all the time. And I think that's the problem when it comes to having hydro. On the other hand, even under diffuse light, you can have more stability and permanency associated with solar that is very useful. So I think mini hydro will, I do hope that we can get more venture capital into Sri Lanka, because you need to have the capital in order to create things. And even in the mini hydro, as you probably well know, there is a lot of legislation and procurement and various permissions that need to be obtained before you can set things up. And then all you need to do is one landowner saying, I don't want your cable going across my land. And you have a problem in supplying it. So I do have running mini hydro projects who generally have a beautifully run facility that suddenly hit roadblocks intermittently due to other sources wanting to profiteer from it rather than anything else. So fully agree with you. It has to be part of the mixed bag. And in particular in Sri Lanka, the 40% or more of the backup power has to come from the hydro end of things.
Thank you. There's a question in the chat. What is the place? First of all, JP Jayasinghe, would you like to ask your question, or shall I read it for you? Or hopefully you're listening. What is the place of domestic solar energy partly contributing to energy demand? Can nanotechnology help domestic units as well?
Right. So I think solar energy can contribute to all of the different areas. And if you look at as a country within the UK, a third of it is for domestic and buildings, energy-wise, and a third is going for transportation sector, and another third goes for manufacturing and industry. So from the home perspective, I believe we should be able to put 1 to 5 kilowatt power systems on people's domestic residences. Will certainly help alleviate some of the problems that we are currently having in terms of grid stability, etc. And in particular, if we can get the homes supplying us that energy, it means technically the load on the national grid will be so much lower, and therefore we don't need to turn on the gas, etc. As we've seen lately, the power stations have run now without any coal power for a considerable period of time. And this is because we do not need the peak power that is necessary with the peak demand matched by what is available within the current renewable sectors. The problems generally come because our storage is not as good as it can be, that we have to sometimes shed load when we have too much wind in the system. But Germany is providing the example at present where they can run months without touching any of their fossil fuels, purely based on renewable energy sources.
Thank you. And Mahila Fonseca in the chat. Thank you for an excellent presentation. What is the place of heat pumps for domestic use replacing gas central heating?
Thank you, Mahila. That's moving to the periphery of my expertise, but certainly I think heat pumps are necessary. At the moment, particularly in industry, I think the CHPs are running at slightly higher temperatures, particularly you're talking about maybe 150 to 170 degrees. But in the future, if we can run things down at 80 to 100 degrees, then the heat pumps will start becoming very much clearer. I think for domestic use, immediately to change is probably going to be slightly problematic. And I think one of the proposals currently that is being looked at is whether hydrogen can be mixed in the gas so that you have more renewable hydrogen being used, and putting of CHP systems with mixed gas fuel intake capability, and using that to power homes.
Thank you, Ravi. Lakshmi Pereira is next, and then Shanta and Lal.
Thank you for a very illustrative and very informative presentation, Professor. My question is, I know this solar and this nanotechnology far outweighs the advantages than if it has any disadvantages. I'm just asking you whether what is the impact on our ecosystem? If there is any, or if there's any impact on our ecosystem, these new technologies?
I think that's a very good question, Lakshmi, and I think that's something that we all are very, very conscious about. And I think that's the reason why I said most often you're talking about 5 to 10 years before many of these products actually see the shelf, is because we need to do many, many tests. Because we are very concerned on the possibility of some nanoparticles becoming embedded within the natural system. So for example, I indicated within the solar cell area, we are looking at organic solar cells. An area in which we can get even higher efficiencies is called perovskite solar cells. But the perovskite solar cells has a little bit of lead in it. So it's lead iodide with methylammonium systems on there. So due to the lead, we have to be extremely careful. Although we may be using only 2 to 3% of lead, if the lead leaches into the ecosystem, that could have significant consequences. So we try to be as careful as possible. Saying that, because the nanoscale structures are so small, it generally will go through most people's systems, and therefore it's not an issue. The problem comes when you have agglomeration of nanoparticles within your system. And in particular, if the nanoparticles were to agglomerate to the micron scales, particularly above 10 microns, 10 to 50 microns, then it goes into the asbestosis type arena where we have to be very, very careful. So I think it's still something that we are learning. We are learning how to deal with it. And provided we can make things small enough, it appears to be safe. And certainly we are running tests, but certainly we are not complacent to say that there aren't any problems. We have to be extremely vigilant, and anything that goes out will be tested significantly before sold to public.
Thank you very much, Professor Ravi. I think it is the size now it's concerned, isn't it? And because it is too small to be compared to the impact it has, very small.
That's correct.
Yes, thank you very much.
Shanta and Lal.
Lal wants to ask.
Thank you, Professor Silva. It was very interesting. My question, I hope it's not a very silly question. It's probably not in your field. I was just thinking, it's from my reading about Nikola Tesla, who thought that you can power the world without any wires or transmitters. I just wonder, I mean, whether it's just fiction or whether there is any truth that can be in there.
Nikola Tesla is an amazing person. I actually visited his hometown in Croatia and the museum just before COVID, so 2 years ago. And he really is one of the most amazing scientists, electronic engineers that have lived. And I think he talked about transmission of information and holographic data, and even the television way before anyone else even thought it was possible. I think his idea of transmission of data is actually electromagnetic waves. So he was one of the few people right at the beginning to say, using electromagnetic waves, we can power things. And that is possible now. So the key here is it's basically a larger version of your radio. So in your radio, you've got a FM and an AM antenna, and you've got a emitting system at your radio station. It sends out a wave, provided you can lock into the signal that is coming through, you can hear and disseminate what the noise that you want. So I think in his view, he said, maybe we can actually expand that radio system to run your whole house with it. So it is possible, but in that manner, you'll need to have very, very focused beams of energy running through without any dispersion in the environment. So it's probably less feasible, but it's a very neat idea. In fact, one of the routes in which solar energy is being considered to be brought to Earth is by having solar panels above the Earth's surface in space floating. And the idea there is that you will have a laser that powers an infrared beam from the space station solar to the base station on the ground. And that allows you to link the energy that is being captured in space to your home base on the ground level. So that is certainly being looked at as a possibility. And the simple reason is that as soon as your solar goes through our atmosphere, it loses 50% of its energy flux. So this allows you to have 50% more, provided you can have it in space. So it's possible, but not feasible at the present time.
Thank you. Thank you very much. Sorry if it's a silly question.
My pleasure.
Thank you. Sorry, Mahendra is next.
I give way to Rohan first, if you don't mind.
Hi, Ravi. Thank you very much for your lovely talk. My question is a little bit futuristic. So at the moment, only small amount of the total energy requirement of the world is being met by solar power. Let's say in another 50 years' time, say 80–90% of the world power is generated by the solar energy. Will that cause any significant cooling effect?
Very interesting point. So it's all about energy balance at the end of the day, and how it is utilized. I guess there will have to be some system correction that has to take place in terms of your system. But clearly, energy cannot be created or replaced. It's just converted from one form to the other. So there will need to be some sort of balancing. But I suspect because the current excess of CO2 in the environment, we probably have a buffer built in. But yes, when we start using large amounts, you're right, there has to be some sort of balancing process that needs to take place. And hopefully that will happen naturally through radiation. And if necessary, it can be augmented also by making sure you can move energy in and out of the atmosphere. But hopefully by that time we would have solved that problem already. But it's a very interesting point, but it does show that in all of these solutions, you also have challenges that need to be looked at in the same time. Thank you.
Thank you very much.
There's a question in the chat, but Mahendra first, and then I'll go to the chat.
Okay, thank you very much. Can I ask you about the batteries that are used in electric cars, with lithium batteries? There's very little spoken about what's going to happen to the batteries that all these cars which are growing like, nothing, after a few years, what's going to happen to them? Are they going to be a problem for disposal, provide environmental hazard? Can we go on getting lithium, or is there a limit to how much lithium we can find? What's the future for that?
It's a very good point, Mahengee. I think I don't know the answer to that. You're spot on all 3 points there. So one of the biggest problems is lithium, whether there is enough of it. Secondly, with regard to the capacity that lithium has, particularly for cars, because once your car battery goes below the 70% efficiency, you cannot use those batteries anymore. So that means it becomes waste. And then what do you do with the waste products? So these are activities that we will have to look at more carefully. I think within the science and technology community, there is a lot of work going on in recycle, reuse areas, because what we do know is that if we use recycled products, the amount of energy that you use in the manufacturing is about 90% less than if you were to manufacture from start. So I think if there is a balance point where we look at lithium use versus removal, it probably will come and hit a particular point. But more importantly, I think there'll be other types of energy storage that come in. So already we have flow cells, and sodium ions are being looked at as a possible way of battery energy storage. So there will be other elements that come in. Lithium on its own is not the most efficient because you can only have one-to-one associated with the storage of charge. So there are other material systems, particularly if you can have silicon anodes, it becomes much more stable and efficient. So there will be other material systems that come in. But after this talk, I'll send you a editorial that I've written that actually talks about it.
Thank you very much.
Okay, so going to the chat, Ranjan Gunasekara asks, is there any place for ocean thermal energy conversion?
I'm not an expert in thermal conversion, so I don't know enough about the capacity of ocean thermal conversion. Certainly there is a whole field that is not just looking at ocean thermal conversion, but also looking at thermal generation, where you can actually bore a hole and have the thermoelectrics driving it because of a Seebeck effect of the temperature difference between two places driving electrical charge. But I don't know enough, but I don't think it will form a major part. The larger part that is likely to form is on tidal wave energy. And there is a lot of associated work currently going on in Wales and in Strathclyde, where there are tidal changes going up to 8 to 10 meters. And that is allowing you to create a lot of energy, mechanical energy, through their tidal system.
I think the problem is that I encountered this thing when I was in Japan, because there was professors who were working on this ocean energy, ocean thermal energy conversion. Because, for example, like in Trincomalee, like near the harbor, it's sort of sea goes something like about 5 kilometers down. So yes, the water is so cold, and so most of the places, and they have ships and things like that in the middle of the ocean. And because you need to have something like 1,400 feet below the sea to get the cold water, and then when it comes up, it becomes like hot water. Then they have the energy. Because I thought that Trincomalee is one of the best places, because in the harbor itself is about 4 or 5 kilometers depth there, so it is a nice place to have that.
It's a very good point. I do know of one person who looked at it, a retired naval officer, and I think again, if I look at the shore of Trincomalee and somewhere in Eevolution area also, there's some very nice points in which you can actually on shore get very big thermal differences. The problem, I think, is that the materials are not developed enough at present to be able to do it economically. So, but the Japanese would be a good country to collaborate with in order to look at things in that area, because they're the ones who brought superconductors also in. And if you have some large superconductors, you can also reduce the thermal losses associated with the transmission.
Thank you very much for that.
I have two questions, but Ari first, and then I'll ask mine.
Thank you, Professor. It's my turn to ask a silly question. You mentioned about the conversion of energy, that it goes from one form to the other. But once solar energy is dissipated, it's gone, isn't it? And that's part of the question. The supplementary question is, what's the lifespan of the sun?
So the lifespan of the sun is so long that I don't worry too much about it. It's beyond my lifespan, beyond many generations. But yeah, you're certainly right. You know, the stars can die as well as be formed. But I think it's not an immediate threat at the moment. But in terms of the conversion, so effectively, if you think of your sunlight actually comes through electromagnetic waves. So effectively, you've got an electromagnetic wave that is created on the surface of the sun. It takes 7 minutes, 19 seconds effectively for that electromagnetic wave to come from the sun to the earth. And then what solar cells do is it takes that light, the photon, and converts that into electricity. So immediately the energy that was within the solar photon now becomes electricity, and that electricity now powers your electron and hole within your wire. That electron and hole within your wire then will go down your wire into a battery storage or an electrical appliance. And most often when you use electrical appliances, you're wasting the energy as it transmits through your wires, and you're probably losing about 40% of it between the energy source and your point at which you're using it in the transmission. And then it's only about 40% that you actually use as part of the mechanical energy. And that mechanical energy or motor that was used could be used for anything. It's very interesting because the statistics of the different energy generation technologies is such that whether it's oil, coal, gas, nuclear, nearly 60% is lost before it is actually used practically. So it's a strange system. And as a result, it's far better if you can have local smart grids using it and point of use at source. So that's where solar cells becomes probably the preferred way of doing things, with as little energy lost in the transmission process as compared to other technologies.
Thank you very much.
So my questions, two unrelated questions. You mentioned lossless cables, how to develop a cable that can carry current over thousands of kilometers without losing power. So was there a proposal from Germany to develop such a cable?
So the lossless cables basically come from the whole idea of superconductors. And superconductors has been around for 60, 70 years now. The problem with superconductors in the past has been that their TC point, the temperature at which you become superconducting, has been pretty cool. So it started off by needing liquid hydrogen temperatures with 4 Kelvin, then it went on to around liquid nitrogen temperatures of 70 Kelvin. And now you can go probably 100, 150 Kelvin, but still it needs some sort of cooling associated with it. So it's not just about building these superconductors with the necessary compound material systems, it's also building it to scale and then having a system that can use it. The best example of superconductors really is your train system in Japan. You know, the whole train system is working on superconducting cushions. So it's an amazing system, but there's a lot underneath those rails that are used to power it, simply because you need to make sure that your flux, the Cooper pairs, do push the flux of one. So it's just running on top of a cushion, effectively, an electromagnetic cushion, much like a hovercraft as a air cushion. So it's very expensive still.
Yeah, thank you. And the other question was, since you're working in 4 different countries, China, India, UK, and Sri Lanka, what are the cultural differences that you see in trying to implement this? I mean, do you see one country being more dynamic than another in its application? And the problems are economic and societal. Different countries have different problems. But how is the cultural shift? How willing are they? How culturally conservative are they? Or how willing are they to change?
It's a very difficult question. So again, I've got limited experience, but I do have an institute that I'm director of in China called the Jiangsu Genome Institute, where we do materials, genome, computational materials for energy materials to make things. Working in China is a real pleasure simply because you can talk to them about an idea one day and the next day you will have 20 pages of discussion and literature review on your table, simply because the work ethic is very, very strong. And people don't mind working through the night in order to get work done. So it's an absolute pleasure that way. And you need to have a lot of interactions in order to do things. India is slightly more relaxed, closer to Sri Lanka, where it's done during office hours most often, and there is reluctancy within the system to take new ideas in unless it is pushed through from higher up or on the food chain. And I think the UK, on the other hand, is very independent. If you convince someone it's a good idea, they just run with it in a very independent manner with very little advice needed, and sometimes no advice needed, and advice given to you as to why your ideas aren't the best ideas in the world. So it's a very collaborative process that takes place. But the beauty of working with all of these places is that you learn something from wherever you work. And it's an absolute pleasure. It's probably my privilege, most privileged point to have worked with so many people in so many different countries and cultures, because you learn from every single interaction. And I think the biggest problem diplomacy have is not understanding the language. It's people inherently are nice people. People inherently want to work with each other. They want to learn from each other. The problem, the barrier is the language. And when you cannot communicate properly with the language, it becomes difficult. And it's then that many other issues start popping up.
So much lost in translation, going through interpreters. Yes. So I didn't actually see who was first. Was it Mahendra or Ruan?
Yeah, it was me. I know we are running out of time. Is it okay, Ravi, if we have 10 more minutes? Is that okay by you?
Absolutely fine. Yeah, that's fine.
Okay, right. Well, it's more an observation, really, because I don't know whether you will agree with me that things like climate change and lots of other things that we are being faced with cannot be tackled independently. It must be part of a package of consideration. And that's why I was very interested to read the book by Roman Krasniak, which you must have heard of, The Good Ancestor, in which he talks about what's called the intergenerational index, which was coined by economists from Iceland called Jamie McQuillan. But in that, issues like environmental issues, economic issues, social issues all have indices. There are 10 indices, and then you score it, you see. So I would say that things like that will go far in helping us to come to terms with things, rather than just look at a GDP growth, or, who the hell cares about GDP growth when people are suffering and hungry and starving and have not health services. So it's interesting that in the Intergenerational Solidarity League table, Sri Lanka came, believe it or not, 15th. Iceland scores the highest, Sweden, Nepal, Switzerland, Denmark, Hungary, France, lots of expected places, New Zealand, Italy. USA was nowhere near. But to me, that type of thing is a better indicator of what's happening in the world than going by a number of cars sold or a number of houses built or GDP. So what I'm suggesting is that if we want to get further with climate change, the necessity to introduce solar power more widely, it has to be interagency. So people like you are dealing with it will have to deal with economists and environmentalists and politicians and any people who have some kind of power, because these are generational things. This is not just for us. We are talking of future generations. We are talking of looking after the future of generations to follow, not just us. So that's my view. Thank you very much.
Now, I couldn't agree more, man. I think you're absolutely spot on. And I think there is no wonder that people like Greta Thunberg come through these educational systems where, you know, passion takes you a long way. But I'm sure within that, the community around as well as the governance around allowed someone like that to come to the limelight, simply because it's the environment that they are brought up in that allows this free discussion and discourse of ideas. And if it is good, a case of helping to amplify that volume. And I think you're absolutely right. We do need to try to do our bit in working in this way of promoting the dialogue. As I said, on Thursday and Friday, the meeting that I had with the Royal Academy of Engineering and CESA in Europe had two ministers, Kwasi Kwarteng and the Minister of European Science and Technology from Portugal, who gave the final comments of the two meetings. And the only reason they were there was because of the potential importance of net carbon zero to the world and what we live in. But you cannot take the people away from the equation. And as you quite rightly said, this has to be a societal activity that everyone takes part in. So I hope the climate change debate will have many more dialogues and discussions and discourses like the one we are having now, to empower people to actually act on their own and to bring their own networks around. Because without people understanding it, it's a classic example that, you know, any gas that comes out of the UK affects Sri Lanka and vice versa. So we are a single community here. And therefore, like living in society, there are the goods and the bads of people, and there are the people who are more altruistic and others who are less altruistic. So I think everyone needs to compensate for each other and do their bit. And you hope enough people will work together. And probably your index was really about that, how people feel energized and empowered to be part of society. And those countries that you mentioned, Iceland, Sweden, they all have a very nationalistic, broad sense that they belong to a community, to a country, to the world. And I think Sri Lanka used to be like that. We used to be very, very close and empowered to do things, whereas nowadays some of the political parties are changing that view, which I feel quite sad about sometimes.
Thank you. That's a brilliant answer to my question. Thank you very much. Appreciate it.
One is next.
Hi, Ravi. Mine is actually not a question, it's a comment, but I would like you to give me your thoughts on that as well. Throughout the ages, especially in the ancient world, several countries worship the sun. You know, we all know that in Egypt, they call it Ryan worship, and the Peru Inca civilization, they had the sun gods, and more close to our country in Sri Lanka and India, Surya Namaskar in yoga, and even in Sri Lanka, there was a belief that the king has to be descending from the sun. So unfortunately, for some reason, over the past 2,000 years, 2,500 years, we have invented probably new deities and forgotten the visible deity actually who sustains us on a day-to-day basis. So probably, I think the future is now we are giving the sun the rightful place, and over the next 50 years, probably it will be exalted as it was done in the past. That's a comment. Thank you.
I agree. I think at the end of the day, this is a community that's evolving, and different elections and different ideas, ideologies have come together. But the key point is all of these ideas, ideologies are actually about making sure society does good for people. And I think that's the beauty that many people forget. Whatever religion you follow, if you look at the pure religion part, it's a way of life. It's a way of how to live in society and live together. And I think, these are transitional when it comes. There's one thing that has been permanent since the formation of the earth 4 billion years ago. That's the sun. So maybe ultimately that's your God that actually helps create everything. So I have no better answer than that.
Indrajit, would you like to ask your question? It seems to be the last question.
Yeah, that will be the last question. Yeah.
Is this nano solar cells available in London? I mean, in England, where we can buy and install it in our houses?
Some of them are available in it, but not for the consumer. It's available for companies who are using it as demonstrator products. So it's actually not in London. It's available in Germany through Armor, a company called Armor. And then it's also available through Heliotech. And then in Greece, it's available through a company called OET. So there are companies around the world that have these products available. The nano solar cells are also available in the UK through a company called Oxford PV, Oxford Photovoltaics. It's run by probably the foremost solar expert in the UK, Henry Snaith. But they are not selling to the public. They are still in the prototyping stage.
Thank you.
Well, Shihan, shall I speak now?
One's hand is up, but I think he forgot to lower. Okay, yes, fine.
Okay.
Yes.
Right. Well, Ravi, it's my pleasure to thank you for a superb presentation, because it made us think more than anything else. It made us think. It stopped us in our tracks and made us think. And it's always useful to remember that although we are individuals, that we are part of a society, and the society is actually a community of the whole world. And we sometimes tend to forget that and think of ourselves and our problems, and that we have a greater responsibility for the future generation, not just our generation. And the energy aspects you spoke of are so pertinent and so relevant. I thank you from the bottom of my heart. Thank you very much for a wonderful presentation. And can I ask everybody now to unmute themselves, please? Unmute. Okay, let's clap our hands and show our appreciation to Ravi.
Thank you very much. I do appreciate it, and I do appreciate also everything that is done by societies such as the Literary Society, because I think literally that's what makes our world go round. There's so much things that are more than just science and technology.
Thank you. Ravi has kindly consented to it being recorded. So what I'll do is I will produce something and send it to him first, because I want him to be happy with what's going to be produced. And then if he okays it, I'll upload it to YouTube so that it can be seen by a wider audience. And if you have any questions for Ravi after this, if you send it to me, I can forward it to him. And we'll keep in touch, Ravi. It's a pleasure to know you. All the best.
Thank you very much. A pleasure to speak to you. Goodbye and have a good evening.
Thank you. Bye-bye. Okay then, all the best. Bye. Enjoy the rest of the day.